Good day guys, this is your tutor engineer. We are continuing with our series on functions. Today we'll be doing a parabola, a straight line, and a cubic function. Let's start with today's lesson. The figure shows the graph of f and g. A is the point on f, right? So let's just see if you can locate point A. So this is point A, which is the point on graph f, and f and g intersected B. Here is point B. C is a point on F. Here is point C, and D is the point on G. Here is point D. So that CT is perpendicular to OE. Okay, the first question is determine the coordinates of A, the turning point of F. Okay, let's find the coordinates of A, the turning point of F. We'll call, let's say 6.1. Since we're dealing with the turning point of F, let's write the graph, the function of f of x. So at the turning point, we know that the gradient is 0. So let's find the gradient for this function, which is a derivative. 2x plus 6 will equate it to 0. And then we'll solve for x. X is minus 3. That's the x coordinate at point A. Now to find the y coordinate, you'll take the original function and replace x by minus 3. Be careful not to use the derivative when you find the y coordinate. You're supposed to use the original function. So here the answer will work out as 9 minus 18 plus 10, which will give us a 1. So point A is minus 3 and 1. Here let's write minus 3 and 1. Okay, then let's go to the next question. For which values of x is f decreasing? Okay, let's go to the function of f. It's decreasing from infinity up until point A at the turning point. So we will say for 6.2 the answer is when x is less than minus 3 at point A. Then f is decreasing. Now let's go to the next question. Determine the length of OE if CD is 36. Okay, you'll notice that CD is a difference between the function f and the function g. So in order to find the length for OE, we need to find the x coordinate for this line, right? So let's get the difference for f of x. We'll say f of x minus g of x is equal to CD, which is 36. F of x is x squared plus 6x plus 10. G of x we've been given as minus 3x minus 4 is equal to 36. Now let's simplify. Okay, now we can easily find the factors of this quadratic expression. The factor for x squared is x times x. The factors for 22 is 11 times 2, where 11 is positive and x is negative. So if we solve for x, we'll get x is minus 11 or x is 2. Okay, so which one are we going to choose? You will notice that point E is on the positive side of the x-axis, so we choose a 2. To answer the question for the length for OE, we know that here x is 0 and then here x is 2. Therefore, OE is going to be 2 units, right? So let's write here OE is 2 units. Okay, so let's do the next question. Determine the x-coordinate of B. Okay, B is the point of intersection between graph F and G. So we will say where two graphs intersect, they are equal. Okay, so let's just here replace the numbers. So we take the graph G on the left hand side. Okay, so I think here we made a mistake. Graph G is minus 3x minus 4. Okay, I made a mistake here. Let me capture the graph G correctly. So it's minus 3 minus 4. When everything comes this side, will be positive. And then here you'll have x squared plus 9x plus 14, 0. So this is the quadratic expression which you can factorize. The factors for x is x times x. For 14 is 7 times 2. Where they are both positive, so x is either it's minus 7 or x is minus 2. So which one are we going to choose? You'll notice that the graphs intersected point B and at another point here. So that point hit will be minus 2. Then the x coordinate for B is minus 7. So minus 7 would be the answer. Let's come to 6.5, for which values of x is g prime of x and f prime of x less than 0. You'll notice that these are the two gradients. The product of the gradients is negative. Okay, graph G is always decreasing up until infinity, but then graph F decreases up until point A, and then from point A it's going to increase. So the gradients of both graphs will be, their product will be negative, where x is greater than minus 3. Right, so our answer here, we're going to say x is greater than minus 3. Then this condition will hold. Okay, that's it for question 6. Let's go to the next question. The graph of f with equation f of x is equal to this cubic function where a and b and c are real constants, has the following properties. A is greater than 0, so this is giving us the shape of our function where a is positive, and then d is equal to 12. D is our y-intercept, our constant, so we'll say this is giving us the y-intercept. The y-intercept will be 0 and 12. And then f of minus 3, f of 3, and f of 5 is 0. These are the x-intercepts. Okay, we'll say the first x-intercept is 3, minus 3 and 0. The next one is 3 and 0. And then the last one is 5 and 0. And then here f prime of 0 is 0. It's giving us where the gradient is 0 is the turning point, the first turning point where x is 0, and then the gradient is 0. But then to find the value of the y-coordinate of this turning point where x is 0, it's going to be 12, right? when you replace x on each term, you're gonna get f of 0 as 12, and then here is also the turning point because the gradient is 0. So the y coordinate of the turning point is actually this one. So you have another turning point there, 2 turning points. So the question is, use the above information to draw the sketch of f. Clearly indicate all intercepts with the x and y axis as well as the turning points. So let's start by labeling our graph x and y, and then also the numbers. Okay, so let's just say here 1, 2, 3, 4, 5. Likewise, and here we need to make sure that that y-intercept of 12 fits. Let's just say 12 is there. Okay, yeah, I think that's it for now. Okay, now let's label our points. Let's make a point where the graph will pass. We've got the y-intercept there at 12, right? And then we'll have an x-intercept at -3 and 0. It's a point here, -3 and 0. We have another x-intercept at 3 and 5. So we'll mark 3 and we'll mark 5. Okay, this will be also our turning point, that y-intercept, and we'll have another turning point at 4 and -3. Okay, -3, let's put it somewhere here. There's a 4, we'll have a turning point there. So let's draw the function. The function will look something like this. Okay, let's look something like this. It's gonna cross at the x-axis, make a turning point, continue to cross the x-axis, going this way. You can just label it as f. So that's it. Okay, then let's come to this part of the question. We are given the function f of x. The first question is determine the coordinate of x and y, intercept for f, right? So let's write here 9.2.1. Let's start with the y-intercept. You know, with the y-intercept, x is 0. So f of 0, we just replace everything where there is x by 0. So the answer here will be 12. So the y-intercept is x is 0 and 12. That's the point on the y-intercept. And then let's come to the x-intercept, where y will be 0. So we'll have x cubed minus 5x squared minus 8x plus 12 is equal to 0. Okay, to factorize the cubic function, you need to choose the values of x. Gonna choose -1, then you choose 1, then you choose -2, choose 3, and so on and so forth. So it's some sort of an iteration until you get the correct factors. Let's start with -1, right? Okay, if you replace x by -1, let's see if it's gonna give us a 0. If it does give us a 0, then -1 would be a factor. So here works out as -1 minus 5, sorry, minus 5 is times 1. This one will be plus 8 plus 12. Here you'll have minus 1, minus 5 plus 8 plus 12. It's not going to be 0. This is minus 6, and then it's going to be 2. It's 14, which is not 0. Therefore, minus 1 is not the factor. Let's try x is 1 and see if it works out. Let's try this one. So where x is 1, we'll have 1 cubed minus 5, 1 squared minus 8 times 1 plus 12. It's going to be 1 minus 5 minus 8 plus 12, which will be 1 minus 5 is minus 4, and then minus 4 minus 8 is minus 12, and then it's going to give us a 0, this one. So we have a factor. One of the factor is x minus 1. Is a factor. So since x minus 1 is a factor, let's just choose a different color. Let's choose the orange color. Since x minus 1 is a factor, we will have, okay, it means here to factorize this expression, the factors of x cubed is x times x squared, and the factors of 12 is minus 1 times minus 12, right? So now let's find the middle term of this bracket. Okay, the way you're going to find the middle term is that you're going to multiply x and x squared and minus 1. You'll have minus x squared, right? So remember, the middle term must give us minus 5 x squared, right? So which number are you going to add to minus x squared? Then it gives you minus 5. So if you add minus 4x squared, it's going to give us minus 5x squared. So basically you're going to take 4x, right? So here the middle term will be minus 4x, right? Now we can further factorize now this quadratic function. So this one will work out as x. The factors of x squared is x and x. The factors of 12 is 6 and 2, where 6 is negative and 2 is positive, equals to 0. So here you'll have x is equal to 1, or x is 6, or x is minus 2. So the x coordinate is 1 and 0. Here you have 6 and 0. Then here you have 2 and 0. Now, yes, we've answered the first question. Then the second question is the equation of a perpendicular line. Find the equation of the perpendicular line for f at x is equals to 1. Okay, let's go back to our original color, blue, 9.2.2. Okay. The perpendicular line of f at x is equals to 1. First, let's write the equation for f. Okay. The perpendicular line. Okay, we need to find the derivative, the gradient, right? At f is at x is equal to 1, right? Yes, x is equal to 1. Let's first find the derivative. The slope of the function is going to be 3x squared minus 10x minus 8. So the gradient here, the gradient of the line at the point where x is 1, we're just going to replace x by 1 minus 8. Okay, here we'll have 3 times 1 minus 10 minus 8. So 3 minus 10, we'll have minus 7. Minus 7 minus 8 is 13. The answer is 13. So this is the gradient of the function of f where x is equal to 1. But now the question is asking for the perpendicular line to this gradient. So the perpendicular line would be where the gradient, let's say gradient 1 times gradient 2 is going to be minus 1, their product. So the gradient 1 of the function is minus 13. And then you're going to say the answer is equal to minus 1. Then m2 is going to be 1 over 13. Right? So this is the gradient of the perpendicular line, right? So since they want the equation of the line, we have the gradient. We know that the equation of the line, we can write it in this format, right? So in this case, you're going to have m2 there. Now we need to calculate the value for c. We already have the value for m. It's 1 over 13x plus c. So to find the value for c, we can find a point where x is 1, right? Remember, x is 1 there at that particular point. So when x is 1, that means f of 1 is equal to, right? We've already figured out where x is 1, right? We found a 0. So we have a point where this straight line is passing through, where x is 1, then y is 0. So we can quickly calculate for c, right? So y is 0, 1 over 13, 1 over 13, and then here we have 1 plus c. And then here your c will work out as 1 over minus 1 over 13. So therefore the equation is going to be 1 over 13x minus 1 over 13. So that's it. That's it for today's lesson. If you liked the lesson, please subscribe. We'll continue with more questions on paper 1, particularly on graphs, on our next lesson. So stay tuned for that, and cheers.